Now let's look at this application of writing the vector as a linear combination of our unit vectors. So that's where the I and the j is coming in. So with this one, we have dE is the vector, where D, the initial point, is at -2, 3, and then the terminal point is 4, 5. We need to write the vector as a linear combination of the vectors. So first off, we need to find it in component form, which means that we need to go ahead and put dE together into the vector form. We do that by doing x2 minus x1, so that's 4 minus -2, comma, 5 minus 3. So that gives us 6, comma, 2 for our vector dE. Next up, now we need to write it as a linear combination of the standard unit vectors. Literally, ready? All we're going to do is write it as 6i plus 2j. And we're done. If you're thinking, wait, it's not easy. Yes, it's that easy. Let's look at another example. Say we've got d to equal, or you don't even need to write d equals. You could say d is -6, 0, and e is 2, 5. See if you can do this on your own. You need to write it as the linear combination of vectors I and j. So go ahead, pause, try to do this on your own, and then come back. Okay, let's look at this. So in order to do it, we've got dE, and that is 2 minus -6, comma, 5 minus 0. The vector is 8, 5, which means we can write this as 8i plus 5j, and that is it. And actually, when we write it, we don't even need to write those edges on it. You can just write it just like that. So it can go back and forth. If I gave you 8i plus 5j, you could go ahead and write it into that vector with the brackets on the end of 8, 5.